go. Alright, we're gonna go over the Algebra 1 Unit 6 practice test. I'm gonna go over these 10 problems and load it up to Google Classroom as soon as I'm finished. Alright, so let's get to it. Number one, we're gonna break down this radical. Remember, when you are breaking down the radical and it's not a perfect square, then you have to see how it is going to be broken down, meaning how you can multiply to get to this number underneath. A perfect square is something like the square root of 9, all right? So the square root of 9 would be 3 times 3. And then because there's two threes, remember this index here tells you what you're looking for. When you have an index of, right, when there's no number there, there's an invisible 2. Sorry about that. Gotta get used to this new technology. When there is a number there, now what we're going to use this year is simply the invisible number, which equals 2, and then we have the number that equals 3. So that means when you have the invisible number you break down, you're looking for groups of 2. When you have a 3, you're looking for groups of 3. Because there is no group of 3 here, this would just simplify back to square root of 9. Okay, because there is a group of 2 here, now the square root of 9, because there is a group of 2, would just simply equal 3. Alright, so I'm going to take this off. And now we're going to break this down. Remember, every even number, we're looking at the square root of 54, every even number can be broken down by 2. So what you're going to do here is you're going to divide it by 2. 54 divided by 2 is 27. Always bring down your radical. I am getting used to this new technology, so hopefully it will get better throughout the day as I'm doing this. Now you cannot break down 2 anymore, so you're just going to bring the 2 down. But you can break down to 27. That's going to be 3 times 9. Remember, every time you break it down, you're still multiplying. We cannot break down 2, we can't break down 3, but we can break down the 9. So it's going to be 2 times 3 times, and when you break down that 9, it's going to be 3 times 3. Now, because there's no number there, there's an invisible 2. So we're looking for groups of 2. Now, that's the only group of 2 we have. Because we only have one group of 2, we're only going to bring out 1, 3 to the front. That group is going to come to the front as one number, 1, 3. So now what you're going to have left over is 3 times the square root of 2 times 3. Neither of these numbers can be broken down, so this is not as simple as it can be. The most simplest form is 3 times the square root of 6. That would be your answer. Alright, moving on to the number 2. Now we say, which of these is the simplest form 3 times the square root of 7? Is it the square root of 21, the square root of 42, the square root of 63, or the square root of 73? To do this problem, what you're going to do is solve all of these or simplify each of these radicals and see if it happens to equal this. Alright, 21. So what numbers can multiply to 21? Alright, so to multiply to 21, you have to see what are the factors. Remember in, what is that? I almost forgot. Remember in Desmos, you can do that. Let's see if I can split screen Desmos for you guys. Bang. Let's go here. Alright, while I'm waiting for Desmos to come up, I'll do the problems and then I'll show you guys how to go ahead and figure out what numbers multiply into 21. Alright, so we're here. So we're going to go here. I know that 3 times 7 is 21. And they're only factors of 21. Alright, now 3 times 7, you cannot break down 3, you cannot break down 7. So we're going to go ahead and make that as simple as possible, and that's going to be the answer of the square root of 21. The square root of 21 does not equal 3 times the square root of 7, so this is not the answer. That's done. 42, we know we can break that down by 2. So that's going to be 2 times, uh-oh, we got 21 again. We just saw that you can't break down 21, but I'll do it just again how you would do it on a test. All right, break down the 2, right? Because you cannot break down any of these, there is no group here. Your answer is going to go back to the square root of 42. That doesn't work. 63. All right, so now we know that to multiply 63, we can do 9 times 7. Now to break down 9, which we can, although it's a odd number, it's not a prime number, so you can break down 9 with 3 times 3. Just bring the 7 down. Now we're looking for groups of 2 because there's an invisible number there. We do see a group of 2 because we see one group of 2, meaning there are 2 3s, but that equals one group. We're going to bring out 1 3. So now it's going to be 3 times the square root of 7. All right, this looks to be the correct answer, but let's go ahead and see if that's true. So now we're going to break down 73. How can you break down 73? Well, 73 is actually a prime number. So there are no numbers besides 1 times 73 that equals 73. So this is actually the simplest form of 73. Sorry about that. 73. So that doesn't work. Bear with me, guys, as I get used to this. So this is actually the correct answer. So on the test, when you see a problem and it gives you multiples and say which one is simpler, please break it down. All right, let's see if my Desmos is ready to work. If I bring this over, bang, bring it over. Let's go here. Let's go Desmos. I think I have it right there. Yes. All right. Now I have these side by side. So remember, when I want to see the factors of a number, I would simply go 21 divided by x. Now that's going to give me a funny graph here, but this graph represents the numbers that will multiply to each other to equal 21. So if we come to a point here, let's say if you multiply 5, does it go directly to 5? It doesn't get there. But if you multiply, let's see, is there 3 here? 3, there you go. It's going to be 3 and 7 right there. But instead of going through the graph and seeing where all the whole numbers are, you just go to the settings, go to a table, and it would tell you right here. Right now, it's only going to give you -2 to 2. To get the more numbers, to access more numbers, just hit enter. Go to 2, right? You can't do it from up here. Go to the number 2 and hit enter. And as many times you hit enter, that's as many times as you will see the factors of the number that you have put in. In this instance, 21. Remember, we use 3 and 21 because these are the only whole numbers. You're only looking for whole numbers. All right, that's a decimal, that's a decimal, that's a decimal. We don't want that. All right, so back over here. Now we're going to simplify the following expression. This time we have a cube root. All right, so a cube root means we're looking for groups of, that's right, 3. Groups of 3. So we're going to come over here. Let's write it down over here. Let's go 3. Getting a little bit better with this thing. And I know that 9, well, we can do 2, so let's do 2. So we'll do 2 times 27, was it? Remember, you keep that all under your radical. Bring that down again. You do 2 times 9 times 3. Bring that down one more time. Sorry about that. Let's get out of there. And we're going to bring that down. We're going to erase that. And then we're going to come back over here and go 2 times 3 times 3 times 3. Now, we are looking for groups of 3. What I did is a grave mistake that I don't want you guys to do. Remember to write the 3 every single time you go down. Sometimes when you forget to write, you don't go back and look. You just look right back over here. So I actually went back to the top and I always remind myself, well, what am I looking for? I go to the original problem and I say, okay, there's a 3. That means I'm looking for groups of 3. I do see one group of 3. So because there's one group of 3, I'm going to bring that 1 3 outside. So now I have 3 times the square root of 2. That's my answer. All right, now I have 2 times the cube root of 128. So we're going to break down 128 first. Here, remember, always write down the 2 and the cube root every time you do this. So 128 divided by 2, what's that? 64? Was it 64? Yes, so it's going to be 2 times 64. You can no longer break down the 2. So we're going to go here. This one is going to be long, right? If you remember that 64 is 8 is the square root of 64, you can cut it right here and go 2, right? Square root of 3, right? So you'll go 2 times 8 times 8, right? And then you can break these down and you go 2 times the cube root of 2 times 2 times 4. Break that down. And then over here you'll have another set of 2 times 4. Then you'll break these two 4's down. So 2 times the cube root of 2 times 2. Remember, just bring those down. Break that apart. Bring that down. Break that apart. Alright, now, if you've done this correctly, we should have 1, 2, 3, 4, 5, 6, 7. So I'm looking for groups of 3. That's a group of 3. And that's a group of 3. So because I have two groups of 3, two groups of 2, I'm going to bring 1, 2 out to the front. I'm going to bring another 2 out to the front, right? So now that's going to look like 2 times 2. Man, this thing doesn't want to work for me today. Let's see if I can erase that there. So we're going to go 2 times 2 times 2 times the square, the cube root of 2. 2 times 2 is 4, times 2 is 8. So the answer is going to be 8 times the cube root of 2. But let's say you didn't remember that 8 times 8 is 64. And we're just going to go through it as breaking down by 2. So now you're going to get here to 2 times 32. Then you're going to get 2 times 2 times 2 times 16. Right? Then we're going to bring this, we're going to do one more down here. It's going to be 2 times 2 times 2 times 2 times 8. Now, remember, bring your arrows down and then separate it apart. If you remember to do that every time, you will keep track. If you do not make sure you draw those lines, you will lose track. Even I lose track sometimes when I don't bring my arrows down. That's why I always double check everything I do. Alright, so now 1, 2, 3, 4. Then I have 2 times 4. Alright. Over here, same thing, 2 times the cube root. And I have 1, 2, 3, 4, 5, 6, 7. So that's going to be 1, 2, 2, 3, 4, 5. Write that down, 6, 7. Now I'm looking for groups of 3. That's 1. That's 1. See, it's the same problem. It doesn't matter how you break it down. Just make sure you break it down the correct way. So now we are back to the same spot. 2 times 2 times 2 times the cube root of 2. And this is going to equal 8 times the cube root of 2. Alright, moving on. Here, this is just something you can just put right in the Desmos. You don't have to mess around with it. So if you see a problem like that on your test, which I'll open up today for you guys. I'm up early today. I wasn't able to do the video last night, so I'm going to post it hopefully by 7:30 a.m. if everything goes correctly. So here you just go 1. Remember, if you want to change, you don't want to do squared, right? If you want to change that, you can just do 1 and go A to B, right? So that's the variable and that's the variable. So now we go up here and hit 3, and that equals 1. So what this is saying over here is that 1 times 1 times 1 equals 1. Over here we're saying 2 times 2 times 2, and we can just change that over here. 2 cubed is 8, so we know that's going to equal 8. Then we know that 3 times 3 times 3, that's going to equal 27. If I did that right in my head. 3 here, 3, there we go, 27 is early. And 4 times 4 to the third power, 4 times itself 3 times, it's going to equal 64. 5 times itself 3 times will equal 125. And 6 times 6 times 6 is going to equal, what is that, 64 times 6? Oh, 36 times 6, actually. 6, to the third power, 216. And then this is just so you guys, when you see something like this on the test, you don't get freaked out. Remember, 7 to the third power is 7 times 7 times 7, not 7 times 3. And it's going to equal 343. 8 to the third power will equal 512. Gotta get used to this pen. It switches on me. And then 9 to the third power will be 729. So that's still going to be over here. 9, come back. 9 times 9 times 9. And that will equal 729. Alright, we're done with the first part. Alright, so we go to the second part of it, and we do our following. Here, simplify the product of the following, right? So we're going to multiply. Here, we're just going to multiply 2 times the square root of 12. And that's just multiplied by 3 times the square root of 6. What you're going to do here is multiply the numbers outside of the radical, and then you're going to multiply the numbers inside the radical. So first you're going to multiply 2 times 3, which is 6. Right? And then you're going to have here 12 times 6. Now, what does this already look like? We're already breaking this down. So let's just go ahead and continue breaking this down. We know that 2 times 6, and we know that 2 times 3. So we're just going to bring this up here. So we're going to have 6 times the square root of 2 times 6 times 2 times 3. We cannot break down this 2, this 2, or this 3, but we can break down this 6. So we're going to have 6 times the square root of 2. Remember to bring down your arrows. 2 times 3, bring that down, times 2, bring that down, times 3. Now, what we have to ask ourselves is, are we looking for groups of 2 or groups of 3? Because there is no 3 there, it defaults to 2. So I see one group of 2 here, bang. And I see another group of 3. We're going to leave that 2 out. So we're going to bring out 1, 2, and 1, 3. Remember, when you bring these numbers out, they are multiplying. So you have 2 times 3, which is 6, and 6 times 6, which is 36. So it's going to be 36 times the square root of 2. That 2 stays underneath. Now 144 is a perfect square. All right. It can also be broken down by 2. We have broken down these a lot, so I'm just going to say that this is 12. I know that, right? 12 times 12. What I really want to work here, we're going to bring out our group here, is how we break down. I'm just going to leave that there. All right. How do we break down these variables? Remember, we're going to take the variable the same way we take the numbers. I'm going to go ahead and erase this just for space. What do I mean by that? All we're going to do here is just write out x 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What are we looking for? Groups of 2. And why do we do this? Because x to the 12th power is just simply x times x times x times x 12 times. So we're looking for groups of 2 because there's no 3 there. So that's one group, 2, 3, 4, 5, 6. That means there were no left over, so all the x's are no longer underneath the radical because they will all happen to be simplified to 6 groups of 2. That's perfect. So we're going to come back over here and we're going to give ourselves some room. All right, leave that as 12. We're going to simplify this 12x because there were 6, x to the 6th power. That's going to be multiplied by y to the 18th power. Now, to break that down, we're also going to just do y 18 times. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We made it. 17 and then 18. Groups of 2. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. There were none left over. So we're actually going to bring out all the y's. So the answer to this will be 12 x to the 6th, y to the 9th. What you see for the first time is that there's nothing left under the radical. Don't be alarmed if you have a problem where nothing is left under the radical, right? All right, so let's go back here, scroll down. Now, number 8 is one that says identify 2 expressions that are in the simplest form radical. Simplest form means that you can no longer break down anything under the radical. To answer this question correctly, you need to break down every radical and see if it can be broken down again. So the numbers outside, they're helpful, but they don't really have to do with what's underneath the radical. So now they are a part of the problem, so we are going to have to simplify that. But we just have to see here if this can be broken down. Can you break down 8? Why, yes, you can, because 2 times 4. Not only can you break it down, but will it give you a group of 2? So we break down that 4, and we have 2 times 2 times 2 times y. Now we're looking for groups of 2. There's one group there. Now that 2 comes out. Remember, we have our 2xy out here. So now if that 2 is out, we have 2 times 2 times x times y times 2 times y. How would we simplify this? Well, this would just simply be 4xy times 2y. So yes, this is a simplified version of that. Same thing over here. So this is not the answer because we're looking for the 2 most simplified, which means they cannot be broken down anymore. They are simplified to the lowest radical form. Okay? 28. Let's see. Can we break down 28? Well, we know that 2 times what? 14 equals 28. So we're going to come over here. We're going to break that down. 2 times 14 x 28 xy. Remember, I'm still getting used to this, so sorry about the penmanship. Bring that down. 2 times 7, and that's going to be a 2. That's going to be an x. Now we're looking for groups of 2. Can we break down 7 first of all? We cannot. I do see that 2 repeats twice, so I'm going to bring out 1, 2. Right? And we're going to have 28. 2 times 28 times x times y. And now underneath that radical, we're still going to have 7 times x. Okay, now we cannot break down 7. We did break down 28 and we were able to find 2 2's. But to simplify this, we have to do 2 times 28, which is going to be 56. And that's going to give us xy times the square root of 7x. Because when you can't break down the radical anymore, you simply multiply what's left over. All right, so this does not work because we had to break down 28. We did bring out 1, 2, so therefore that doesn't work. C, let's break down C. So now we have 9 times 2. So when we break that down, we have the square root of 9 times 2 times x. Do not forget your x squared. I'm not forgetting these variables here. I just know that 1y is not going to equal 2, so therefore I'm not going to be able to bring out a y. And here, 1x does not equal a group of 2, so I cannot bring out an x. I'm not forgetting the variables. It's just they don't have enough to be broken down because they're single. This is a single variable, so therefore I can't bring out a group of 2. We are still looking for a group of 2 because that is an invisible 2 there. Now we have to break down this 9. So we have 3 times 3. And then we're going to bring down that 2 times 2. We're going to bring down that x times x. Hey, I'm getting better with this pen. All right, now, do we have a group of 2 here? Yep. We have a group of 3. Which means we have 2 3's that are under the radical. That means that we take out 1, 3. So now it's going to be 3 times x squared, right? Times the square root of 2 times x. So your answer is going to be 3x squared times the square root of 2x. This was broken down. That's not an answer. Well, they said it's going to be 2. If we done the first 3 correctly, that means that the following 2 should not be able to be broken down. Now let's see here. You can't break down the x because it's 1. You can't break down the y. How do we know it's 1? Because when you just have nothing there, that defaults to a 1, and that defaults to a 1. There's 1 x and 1 y. We can break down 6 though. So let's break that down. Remember, it's an even number, so 2 times 3 times x times y. Now, what we have here is the broken down 6, which is 2 times 3. So let's see, is there a group of 2? I don't see that 2 repeats, and I don't see that 3 repeats, and x doesn't repeat, and y doesn't repeat. So the most simplest form of this is to go ahead and multiply 2 times 3, and it's going to be x squared, x cubed, times the square root of 6x, y. So could we break this down? No, we could not. So that's an answer. That's good. Now, we're going to break down 15. We can break down 15, and we can break down x. We cannot break down x, but we can break down 15. This is just going to bring us 3. We cannot break down 3 because it's a prime number. We cannot break down 5 because it's a prime number. So what we have to do now is just simply put it in the most simplest form. So that's just going to be x squared y squared times the cube root of 15x. So we were correct. The two answers were D and E. Now we're over here and we're breaking down, assuming all variables represent positive real numbers, simplify. That just means it's not a zero, because 0 would just be 0, and then that would make everything 0. You can't have a square root of 0. And right now we don't want to deal with that. So what we're going to do is break down the 45, and we're going to break down the x, and we're going to break down the y. Remember the um, exponent simply tells us how many times that x is underneath the radical. So I'm going to go over here, and we're going to start this with 45, square root of 45 times x to the 8th power times y to the 21st power. All right, so that's going to be 9 times 5, x to the 8th, y to the 21st. You can break down 9, so it's going to be 3 times 3 times 5 times x to the 8th, and then y to the 21st. So you're going to break these down individually. I do see a group of 2, so that 3 is going to come out. So we're going to have 3 space times the square root of 5, right? Because there's only one 5, so that 5 is going to stay. So now let's do 8x 8 times. 6, 7, 8. That's a group. That's a group. That's a group. And that's a group. We have 4 groups. 1, 2, 3, 4. So you guessed it, we're going to bring out 4 x's. So it's going to sit here. We're going to have x to the 4. Now, we didn't leave ourselves enough space, so we're going to have to come back. Let's say I'll write the rest of that up here. So it's going to say 3x, right? Give us a space for the y, and then 5. All right, now we're going to go ahead and break down y to the 21st. Yes, I'm going to write this out 21 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We made it. I can count to 21. All right, so now I'm going to go ahead and do that. 1, we're still looking for groups of 2. 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, we had 10 groups. So that means we're going to bring out y to the 10th. But wait a minute, we did not have a group for this y. So what happens with that y? It stays there. So your answer is going to be 3x to the 4th. I forgot to write my 4. Y to the 10th, 5y. That is the answer for this problem. All right, last one. All right, identify each expression, all right, that is in the simplest radical form. All right, so we're looking for radicals that can no longer be broken down. All right, so we know that 4y here, we know that y can't be broken down. There's no number, there's only one y. We're looking for a group of 2. So this cannot be broken down anymore. That works. We can break down 20. Let's go ahead and break this down and see how you would do this on a test. So let's say you had x squared 20y, right? We break that down to be 5 times 4. That's a y, forgive me. And we do have 4, so we're going to break that down. And that's going to give us 2 2's. And we're going to have x squared times 5 times 2 times 2 times y. And we're looking for groups of 2. I do see that there is a 2 that repeats. Bring that outside. So I have 2 times x squared times the square root of 5 times y, and your final answer would be 2x squared 5y. All right, letter C. So B was able to be broken down, so we can't have that. B is going to be 18. Can we break down 18? We can break down 18. So we're going to have the square root of 9 times 2, and then we'll have x to the 4th, y to the 5th. Now, we can break down 9 as well. So we'll have 3 times 3 times 2. And then let's go ahead and just draw these out right now. 1, 2, 3, 4. And then 1, 2, 3, 4, 5. So we're still looking for groups of 2. I do see a group of 3 that can come out. I see 1, 2 x's that can come out. And I see 1, 2 y's that can come out. So now what's going to happen is 3 times x times y. That's a y, ladies and gentlemen, times y, times the square root of 2 times y. Remember, you can't leave it like this. You're going to go ahead and multiply it back. So that's going to be 3x squared. Remember, x times x to the first power times x to the first power, simply adding. So that's x to the second power. And that's going to be y to the second power, because that's 1 times 1. And then you're just going to go ahead and simplify that to 2y. All right, ladies and gentlemen, that is your test review. I would study this, and then I would go ahead and take the test. I'm going to make the Unit 6 Part 1 test open for you guys later this afternoon, and I'll just keep it open to the 24th. It's on you. I'm just going to leave it open. It's on you to go ahead and take the test. You take it when you get ready. All right, you guys. Good luck. I hope this helped. Have a good one. Look out for the other two. I'm going to do a 6-part 2, and then I'm going to do a 7-part 1. All right, you guys. Bye.